rate of change. What can rate of change represent? So today we'll focus on the meaning of rate of change in various situations. What does a rate of change represent? How can you use it as you graph the results of a competitive tricycle race today? Think about how the participants' rates of change compare to each other. So the big race, heat 1. Before a big race, participants often compete in heats, which are preliminary races that determine who competes in the final race. Later in this chapter, your class will compete in a tricycle race against the winners of these preliminary heats. Don't get excited, no real tricycles involved. In the first heat, Leslie, Kristen, and Evie rode tricycles towards the finish line. Leslie began at the starting line and rode at a constant rate of 2 meters per second. So I'm going to say Leslie went y equals 2x. Oh, that's kind of weird. I don't know what just happened there. Y equals 2x plus 0. She started at the starting line and rode 2 meters per second. Kristen got an 8 meter head start and she rode 2 meters every 5 seconds. So Kristen went 2 meters every 5 seconds, and she got an 8 meter head start. And Evie rode 5 meters every 4 seconds and got a 6 meter head start. So Evie rode 5 meters every 4 seconds, and she got a 6 meter head start. So on a neatly scaled axis, graph and then write the equation in terms of x and y for the distance Leslie travels. Let x represent the time in seconds and y represent the distance in meters, so we've already kind of made that decision. Then do the same for Kristen and Evie using the same set of axes. After how many seconds did Leslie catch up to Evie? How far were they from the starting line when she caught her? Confirm your answers algebraically and explain how you use your graph to justify your answers. The winner of this heat will race in the big race. If the race is 20 meters long, who won? Use both the graph and equations to justify your answer. How long did the race take? And then the newspaper reports wants report of Kristen's speed. How fast is Kristen riding as a unit rate? So let's do that one, and then the rest of it, obviously, I'm just going to jot these things down, and we'll transfer those over onto a coordinate plane. But Kristen was going 2 meters every 5 seconds, right? So how fast was she going as a unit rate every 1 second? So I think one of the easiest ways to do this is just to cross multiply and get 5x equals 2 so that I know that I need to divide. X will equal 0.4 meters. So she was going 0.4 meters every 1 second, which meant that she was going 2 meters every 5 seconds. Hopefully that makes sense. So again, I'm going to jot these things down, go to a coordinate plane, and just sort of discuss what's going on with these. What we had here was Leslie started at the starting line, and I hope I have enough room here. I guess I will. I guess I should make this thing a little bit smaller so it all fits. There we go. All right, so Leslie started at the starting line, and she went 2 meters every 1 second. So her progress looks something like this. We can go ahead and use our straight line tool, and I'll just go ahead and fill this in. This is Leslie. Actually, I'll put it over here. Ugh, one too many. Oh no, it's gone. Disappointing. All right, so we'll say Leslie, and her equation was y equals 2x. All right, Kristen was given an 8 meter head start, and again, actually, I guess I should have said this. This is seconds. Excuse me, let me pause for a second. Long interruption. I forgot where we're at. I think it was naming the x and the y. So the x was seconds, and the y was, let's see if I can do this here, was distance. That's not going well. That says distance. You're just going to have to trust me on that. I had to turn my stylus sideways and that didn't go well. All right, so the next person that we had started with a K. I have no idea what their name was. Let's see here. I was helping my daughter with some math. The next person was Kristen and Evie. Okay, So Kristen got an 8-meter head start and went 2 every 5. So 2 every 5. So it looks something like that. Oh, actually, you know what would be good is if I change the colors there. So let's make Kristen change. Oh, I kind of missed that point right there, didn't I? Whoops. So that point should be right there. My mistake. I apologize. I'm discombobulated right now. So Kristen had the equation y equals 2/5 x plus 8 because she got the head start. And then finally we had Evie, who got a 6-meter head start and went up 5 and over 4. Over 4, up 5, over 4, and is going to kind of go off the list there a little bit, I think. So we'll just extend this. Oh, whoops. Man, I'm really struggling right now. All right. Okay, something like that. All right, and then we'll say Evie had the equation of y equals 5/4 x plus 6. Now, I don't remember all the questions that were asked, but essentially, obviously, Kristen was the lead because they had the big shortcut. I shouldn't say shortcut, the big head start. Evie passed a little bit after 2 seconds, it looks like. Then Evie was in first place, and then you can see right about here, what about 8 seconds and 16 meters, they were tied. And at that point, Leslie overtook the lead. You can see Leslie took 10 seconds to go her 20 meters. Evie took a little bit over 11. It looks like Kristen's still pedaling out there. And you can see that Leslie passed Kristen at 5 meters and 10 seconds. And I think it said to actually do a little bit of algebra here too. So let's prove that y equals 2x equals, I guess I should say it equals y equals 5/4 x plus 6. Right here, like we talked about at 8/16. So hey, look, they both equal y, so they both equal each other. So I'm going to go ahead and use some elimination here. Oh, wait, yeah, actually, we haven't learned this yet. I'm sorry, I just made these videos for it, but we're not this far along. So I guess what we would do, it would make more sense, is let's plug 8 in here for x, and you can see we get 16 for y, so that works. And then here, if I plug in 16 for y, and I plug in 8 for x, you can see I'm going to get 16 equals 10 plus 6. So there we go. We solved it algebraically that this one is true. We can also solve algebraically that this one is true. We can say that y equals 2x, and we want that to be equal to y equals 2/5 x plus 8. And we think that happens at 5/10. So let's plug in 10 for y and 5 for x. So you can see that's true. And then over here, same thing. We'll plug in 10 for y. We will plug in 2 for x. We'll plug in 5 for x. Those will cancel, and I get 10 equals 2 plus 8. So that works as well. So we feel real confident about what we've done here. It looks like a mess, especially with all the algebra that I did here, but it does confirm that they pass at 5 meters and 5 seconds and 10 meters. Here they pass at 8 seconds and 10 meters, 16 meters, etc. I'm really having trouble. Sorry. All right, let's go with what am I on? 222, I think, at this point. I'm like completely out of sorts. I helped my daughter for kind of a long time, so I'm a little bit confused as to what I'm doing and where I'm at. All right, so the big heat race the big race heat 2. So we did heat 1, now we're going to heat 2. It says in the second heat, Elizabeth Kay and Hannah raced down the track. They knew the winner would compete against the winners of the other heats in the final race. When the line representing Kay's race is graphed, we get y equals 2/3 x plus 1. Her speed was obviously 2 meters every 3 seconds. 2 meters every 3 seconds. Head start, she got a 1 meter head start. 1 meter head start. Elizabeth's race is given by the equation y equals 12 16ths 12 16ths x plus 4. So again, that means 12 meters every 16 seconds, but I would simplify that. 4 goes in here 3 times, and 4 goes in here 4 times. So I think it's better to say she went 3 meters every 4 seconds, and that she got a 4 meter head start. Who's riding faster? Well, this would turn into 0.75 as a decimal, and this would turn into 0.66 as a decimal. So I think that actually Elizabeth must be riding faster. How do you know? Again, you can go to unit rate, right? This is 0.75 over 1 and 0.66 over 1. So 0.75 meters over 1 second is faster than 0.66 meters over 1 second. So just making it a unit rate. So just as she started pedaling, Hannah's shoelace came untied. Being careful not to get her shoelace tangled in the pedal, she rode slowly. Hannah's race is represented in the table below at what was her unit rate. Well, again, this is our y, so we can see our y changed by 4 every time her x changed by 14. So her slope is her change in y over her change in x. So it would be 4 over 14. Again, we can call that 2 over 7. So 2 meters every 7 seconds. So not very quick. All right, and then to entertain the crowd, a clown rode the tricycle in the race. His race can be modeled by the function y equals 20 minus x. Without graphing or making a table, fully describe the clown's ride. Well, let's take a look here. The starting point is 20, and he's going backwards 1 meter every 1 second. So, his starting point, and I know they told me not to, but what it looks like is the clown is riding backwards, right? He started at the end line, and he's riding to the starting line. He's a crazy clown, right? So if we just look at that, you can see that's what's happening. His distance is 20, and it's going down 1 over 1 back to the starting line, right? So that his distance is 0. So it takes him 20 seconds to ride backwards through the entire race. That was 222 part 1.